Alright, welcome back. Today we're looking at the idea of concentration, and more specifically, not just any concentration, but concentrations measured in molarity specifically. So the objective of today's video is going to be, I can represent the amount of solute in a solution in terms of molarity. I want to notice these important vocab words that we're going to be working with today. Solute, solution, molarity. We're going to add a couple more to that list. So to be able to talk about the concentration of something, we need to look at a solution of something. A solution is just something dissolved in something else, okay? Two things put together. So we're going to take a very simple solution today. We're going to look at something dissolved in water. Got H2O. We're going to do something simple like table salt. Here's my awful rendition of a salt shaker. Okay, most of us know that the main component in table salt is good old NaCl. So a little sodium chloride. We're going to put our sodium chloride into the water, and we know that it's going to dissolve. We've pretty much all experienced this. Now we have some vocab that go along with this. First is, we have the thing that we are dissolving, the thing we're putting into our liquid here. That is going to be what we call the solute. The solute is what you would dissolve. We have the thing you dissolve it in this case the water. That's going to be our solvent. And together, the solute and the solvent, once it's all dissolved, is going to make a solution. So the solute is dissolved by the solvent to make a solution. Kind of got a lot of S's to keep track of, so you got to get those vocab words straight. Now, when we dissolve salt in water, we know that salt's not really just NaCl, but really an Na ion and a Cl minus ion that have been stuck together. When we put that into water, the water actually pulls the two ions apart, and we'll talk later in a video about intermolecular forces, why that occurs. So you can picture that NaCl is really, when salt gets dissolved in solution, it's really composed of Na pluses floating around and Cl minuses floating around that have been pulled apart into solution. We also know that when we dissolve salt into water, we can't see the salt anymore. And it's a very clear solution. So what chemists need to do is keep track of how much salt we've actually put into this water. Okay, that's a key piece here. So if I want to keep track of that, I'm going to use a measurement of concentration. In this case, we're going to use molarity. So we're going to focus on molarity today. Molarity is going to be defined as the number of moles of solute. Let's focus on that again. Solute, how much stuff we're dissolving, in 1 liter of solution. Notice this isn't solvent. Solvent would imply that we'd had 1 liter of water and then we put NaCl in. Now, it's conceivable to think that when we add NaCl into water, it's going to cause this thing to get bigger. Okay, it's going to expand our solvent. So when we're talking about molarity, we're talking about how much of this we put in per 1 liter of the thing when it's all said and done. In lab, we'll talk about how chemists keep track of that component. So mathematically, we can define this as moles per liter of solution. So we can create an equation that represents this. So we'll start with M. M stands for molarity, big M that is. Little m is for mass. So we have molarity. And we know that molarity is going to be equal to the number of moles, or N, and we'll universally use N for the number of moles throughout chemistry here, divided by per volume of solution. I'm going to write volume here, but it's important that we distinguish the fact that this isn't just any volume. It's going to be the volume of solution that we need to worry about. So molarity equals N over V. Now we can rearrange this equation however we need to get an appropriate equation, okay, to solve for any of the other variables. But most of the time you're going to see it in the form M equals N over V, or mass molarity is equal to number of moles divided by the volume of solution. Okay. So let's do an example problem so we can talk about see what we're talking about here. So in my example problem, if I take 25 grams of salt and add it to water to create a solution with a total volume of 250 milliliters, what is the molarity of the solution? Now, whenever I'm doing this, I like to create a picture, kind of get an idea of what's going on here. So imagine a beaker. In my beaker, I'm going to put 25 grams of NaCl. Okay, 25 grams of NaCl. I'm then going to add water to this, allowing my NaCl to dissolve into solution. I'm just going to show this as dots, kind of represent that it's dissolved at this point. And at the very end, the total volume of the solution is 250 milliliters. Okay. So what is the molarity of this solution? What is the concentration? Is effectively what we're going to try to find. Okay. Well, we know the equation here is molarity equals the number of moles over volume. Get these out of the way. So molarity equals N over V. The problem is I don't have the number of moles, but I do. It's actually hidden right here. If you'll remember from our last two videos, we found a way to relate the mass of a chemical to the number of moles of that chemical. So that's the first thing we're going to do. For sake of space, I'm going to lose my picture here. So I'm going to take the original 25 grams of NaCl that I dissolved in solution, and I need to get that into moles of NaCl. It's going to be important. So how do I get from A to B? Well, I'm going to use molar mass. Anytime you're going from grams to moles or moles to grams, you're going to use that. So if we look at molar mass for sodium chloride, I know that looking at a periodic table, I'm going to round this to 3 significant figures because I have 3 sig figs here, 3 sig figs there. Sodium weighs 23.0 grams. I also know that chlorine weighs 35.5 grams per mole, that is, or AMU. So together, NaCl is going to have a molar mass of 58.5 grams per mole. So I can easily convert this 25 grams into moles with a simple conversion. If we do the math here, you end up with 0.427 moles of NaCl. So we've got our first component. We've got our first bit here. So this is our N. Now I just need our volume. Well, our volume was kindly given to us in the problem. It's 250 milliliters. Now, I'm not going to use 250 milliliters, though, because if you'll remember back to our definition states that it's the number of moles of solute in 1 liter. Liter is a key word here, meaning that our volume needs to be converted. So I'm going to take that volume of 250 milliliters, 0.milliliters, and knowing that there are 1,000 milliliters per 1 liter, we're going to have 0.250 liters of solution when it's all said and done. Hopefully we're to the point now where we can do this calculation in our head. It's just a matter of taking that decimal and moving it 3 spots. So now I have my two numbers. I have my 0.427 and my 0.250 liters. So I'm just going to come in and plug those both into my equation now. So the molarity of my solution is going to be equal to 0.472 moles of NaCl divided by 0.250 liters of solution. Just divide, you're going to end up with make sure I got my numbers right, 1.71 moles per liter of solution. Or another way we'll write this is 1.71 molar. We'll just use a big M to represent molarity. This is the final concentration of that solution. Now, for fun, imagine we wanted to know exactly how many of these NaCl's we actually dumped into the water. So I'm going to leave that one to be a challenge problem for you. I want to know how many molecules of NaCl were actually dumped into that solution.